Yes, hi.
Hello.
Hi. Shall we get started?
Yeah.
Okay, so today we'll do algebra.
Mhm.
Let me know once you're able to see my screen, please.
I can see your screen now.
Okay, fantastic. All right, so we will start with basics, keep building up our level. So algebra is a very scoring section on the quant, which also means that we should be ready for some tough varieties. Yeah.
Yeah.
So we'll try to cover as many fundamentals as possible. So algebra is a big area as well, right? So there are equations involving one variable, two variables, there are quadratic equations, there are inequalities. Yeah, so polynomials. So these are some examples of what could be asked within algebra. And we will also go through typical question types today, which will help you get more familiarized with what can you expect on the real quant. Yeah. So let's get started. Okay. So the first type of problems would involve a single variable, which means you'll typically have two sides to the equation, LHS, RHS, which will involve the variable and the constant. And a typical standard procedure is to isolate the variable onto one side, whichever is easier. So generally we isolate on that side where we get a positive coefficient of the variable. For instance, when I look at this equation, this 6 is higher than 3. So typically what we will do is we will try to shift 3x on the other side and this constant on the other side. So hence that makes it, so when minus 3 shifts on the other side, it becomes 5. 3x shift on the other side becomes minus 3x. So this becomes, this looks like this, correct? So we have 2 of 2 plus 3 equals to 6x minus 3x. So we've shifted some variables and this is what we get. So x is equal to 5 by 3. Right. In the second example, we observe that coefficient of the LHS variable is higher, right? So we try to shift this on the LHS and the constant on the RHS. When we do that, it becomes 7 minus 4, so 3y square equal to 18 minus 6, which is 12, and then y square equal to 4. Now, on the GRE, whenever we are given a square, if I take the square root, the answer is plus minus 2. Okay, so just make a note of this. Whenever squares are given and you have to take a root, the answer could be plus minus 2. It can also be written as mod. Yeah.
Mm.
So this is something which needs to be taken care of. Whenever we do a square root, the answer could be plus minus 2. Correct?
Yeah.
So this is how it looks. So isolating the variable, understanding which coefficient is higher. So bringing the other term on that side and then placing all the variable terms on one side of the equation and the constant terms on the other side. All right, so let's get started with the first question. So 12x minus 46 is minus 18 plus 5x. So now this is called as a quant comparison problem. These are commonly seen in the exam, unique to GRE. And typically what happens here is that you're given the question stem, some context to the problem, and then you are given a quantity A and B, and they ask you to compare A versus B. So these are the four standard options when it comes to quant comparison problems. So the first choice is always A is greater, second is B is greater, C is both are equal. D is you can't determine which one is greater or lower. Yeah, so this is common across all quant comparison questions. So we need not even see this. As soon as we start practicing, we know, okay, option A will be A is greater, B will be B is greater, and so on and so forth. So let's solve this. Again, isolating the variable. So we observe that coefficient of x is higher here. So bring this 5x on the other side and the constant on the RHS. So when I do that, I get 12x minus 5x equal to minus 18 plus 46. So 7x equal to 28. So x is 4, right? So if x is 4, clearly b is greater than a. So the answer is this. Yeah, so these are quant comparison kind of problems, a common feature on the GRE. I will also just create a copy of this because we want to have separate annotated PPTs. Okay, easy, right?
Yeah.
Okay, now this one. So Jacob has $0.65 in his pocket consisting of P pennies and 9 nickels. So quantity A is P, which is the number of pennies, and B is 20. Now to solve this problem, clearly we need to understand or know what is pennies and what is nickels, right? So for that, what I've done is, so this is a very important chart which helps you understand the conversion. So when you talk about a penny, it's like 1 cent.
Mhm.
The value in dollars is $0.01, 1/100th of a dollar or 1 cent. That's penny. Nickel is 5 cents. So that's nickel. Dime is 10. D for 10. Deck. D for dime. D for deck. So 10. Quarter is always 1/4. So it is 25 cents. Half is 50% of a dollar. Yeah, so these are typical conversions. The first three are important. Penny is a cent. Once again, nickel is 5 cents. Dime is 10 cents, right? Usually when GRE asks questions on currencies or on these kind of, coin types, generally they might give you that the conversion also along with the question stem. So what is a penny and what is a nickel? But just in case if they don't give, we should try and remember this. So just 2 or 3 things to remember from this table. So with this knowledge, can you attempt this question now?
Mhm.
So Jacob has 0.65 in his pocket consisting of P pennies and 9 nickels.
C.
Correct. Both are equal. So on the GRE, especially to tackle some more tougher constructs, we will get into a habit to create structured tables where we can note our data. Yeah. So for instance, a tabular format of this data will be penny nickel value per penny, value per nickel, and the quantities. So clearly, total for penny will be 0.01 p, and for nickel will be 0.05 into 9. And clearly, it's given that he had 65 cents. So the addition of these two is equal to 0.65. So 0.1 p equals to 0.2. So p is 20. So answer is C. So this is the important part of structuring data in a tabular format. There are two advantages. One, it helps you construct the problem better, solve a more complex problem, which otherwise you might get lost and waste a couple of more minutes than required, or even not be able to solve a complex construct. Second is it reduces errors as well, because it brings clarity in terms of solving. So we will always try to create data in the form of, wherever possible, structure the data in the form of some table. Easier to comprehend, easier to solve, lesser errors while solving.
Sorry, I have one question.
Yes.
What is that thing written under value?
Which one?
It's right under value. There's
Quantity. Yeah.
something.
QTY. Sorry.
Oh,
Quantity.
okay.
Yes. Right. Shall we proceed? Okay.
Yeah.
Next one. So this is a word problem. Can expect word problems as well.
Mhm.
So in 2 years, Huan's age in years will be twice what it was 4 years ago. So what is the age now? So in word problems, first of all, understand what is the variable. Identify the variable. Second is the equation. So variable here clearly is what is the age now? So can we say that is X? So usually your question stem will answer regarding the variable. So what is the variable? So generally your question stem will help you understand what is the variable. So age is X. X is the age now. Now the equation. So in 2 years, so can I say in 2 years means in the future? So plus 2, which is X plus 2, because X is the age now. Yuan's age in years will be twice that what it was 4 years back. So age 4 years back, can I say will, if the age is X today, 4 years back is X minus 4. And now we are ready to create our equation. So as you can see, what I'm doing is, as soon as I start reading, once I understand what is the variable, I am also jotting down in each part how is the variable getting transformed. So in 2 years means X plus 2. In the second stem, it is 4 years back, which is X minus 4. And now it's easy to create the equation. So Yuan's age in years will be, in 2 years, will be twice what it was 4 years back, which means in 2 years, which is X plus 2, the age will be twice of what it was 4 years back. So this is how we will construct it. Obviously, something which is more will be on the LHS, something which is less will be on the RHS, because we are multiplying it with a constant or a coefficient here, or a multiplier, correct? So that's a cross check which you should do. And now we can solve this. X plus 2, open the brackets, 2x minus 8. X on this side, minus 8 on the other side, gives you X equal to 10.
Sorry, could you say that again about the LHS and RHS when it's on the RHS?
Sorry, you want me to repeat this part?
You said something about it being on the RHS when it's greater or less. I'm not sure.
Yeah, so I said, so when I look at this equation,
Yeah.
the coefficient here is higher than on the LHS.
Okay.
So then I will shift this variable term on the RHS. I'll shift the constant on the LHS. And we get 10 equal to X. So that's our answer. Yes?
Yeah.
Okay. Next one. On the GRE, you will find questions which have choices like these.
Mhm.
You will have questions which are comparison questions like these. And some questions, there are no choices like these. So there will be a blank here. Okay, so you'll have to fill the value. So it's possible that you get a question with a blank, I mean, with no choice, and you'd have to just fill the blank. So here we have 2xy minus 3 equal to 4x minus 15, which means we are dealing with two variables, x and y. No worries. What is the value of x when y is equal to 5? So value of y is given, which can be directly substituted, correct? So when we do that, this equation becomes 2x into 5 minus 3 equal to 4x minus 15. So 10x minus 3 equal to 4x minus 15. This coefficient is higher, so I bring this term on this side and the constant on the other side. So this becomes 6x equal to 18. Yes. Or rather, it is minus 15 plus 3, so it is minus 12. So x equal to minus 2. Yes, so just be careful while transferring the terms. So when minus 3 goes on the other side, it becomes plus. So minus 15 plus 3 is minus 12. This is 6x and x is minus 2. So this is the answer. And always cross verify. Yeah. So 5 into minus 2 into 2 is what? Minus 20. And minus 3 is minus 23. So this is your LHS. And your RHS is 4x minus 15. X is minus 2. So minus 8 minus 15. So minus 23. So it's solved correctly. On the real exam, you might not have time to do all of this. But if you have time towards the end of the paper, when you are reviewing your questions, you can just do a quick comparison. For those questions where you feel that you need to go back and just review them once. Yeah, so review is always towards the end, if time permits. So this is a validation, review or validation. Should be done towards the end if there is time, otherwise no need to do this. Validation should be done for those questions which do not have choices, where you need to go back and check again if you've done it right or not. So plugging in your answer back into the equation will validate. So validation process is more important for non-choice or non-MCQ kind of setups or questions. And what is the validation? Whatever is your answer, plug it back into your equation. Plug it into your equation and check if both LHS and RHS match or not. Yeah, so this is a typical validation check, mostly done for non-choice MCQs, non-MCQs variety of questions. Cool?
Yeah.
Okay. So that was the first part, which is equations involving just one variable. Now come equations which involve two variables. Generally, these are called as simultaneous equations. Generally. And these can be solved in two types, in two ways. One is using substitution and the other using combination. I will explain what this is. So whatever you're comfortable with, you can use that method. So now system of equations typically involving more than one variable. All right. So here we have, say, two equations, x plus y 5, x plus 2y 10. Now there are two ways of doing this. Clearly we want to find the value of x and y which satisfy both these equations, which means we need to simultaneously solve these equations. Two ways. The first is substitution method. I will show both. First method is substitution. In substitution method, I will isolate one variable. So I know x plus y equal to 5. Can I say this is equation 1 and this is 2? So from equation 1, I know x plus y is 5. I can write this as x equal to 5 minus y. So I take y on the other side and express one variable in terms of the other. So isolating x. Yes, and once we do that, we can plug it back into 2. So this becomes, so your x will now be 5 minus y, then you have 2y, and then you have equal to 10. And continuing to solve, minus y plus 2y is y, and 5 I can take the constant on the other side, on the RHS. So it becomes y equal to 5. Is that right?
Yeah.
Okay. So if y if y is 5, can I say x is 5 minus y, which is 0. So the solution becomes 0, 5. In terms of, so one way is to look at it from an algebraic perspective. The other way is to look at this from a perspective of two equations, or two graphs rather. And these can also be plotted. So we can plot these two lines, and then the intersection is the solution. So graphically, when I have two equations, 1 and 2, and if they intersect, it will have a solution, and at the intersection, that point is going to satisfy both the equations 1 and 2. So graphically, it looks like this. So that's the first method. Second method is combination, which means intelligently trying to understand what can be eliminated by directly working at equation level. There are two types of combinations, either add or either subtract, depending on what is the construct. For instance, here we have second equation as x plus 2y equal to 10, and first as x plus y equal to 5. Now, when I subtract 1 from 2, clearly one variable will get eliminated, which is x. So I can write x plus 2y equal to 10 as the second equation, and the first equation as x plus y equal to 5. I can subtract these two equations, and I end up getting y equal to 5. And if y is 5, I'll substitute back in 2 in 1, and I get x equal to 0. So adding subtraction at equation level, which means I'm adding subtracting one equation from the other. I might also multiply one equation with a constant if there is a need for that. So basically, we want to immediately eliminate one variable. Usually combination is what I use. It's fast. As you can see, it's very fast. Instead of putting in substitution, you need to convert one variable in the form of the other, then substitute back. I think it takes 5-10 seconds more. This is very quick, but for this you need to be fast in terms of your understanding how this can be, one variable can be eliminated. So here it is easy, both are x, so just subtract the two and you will find the answer. Got it?
Mhm.
Even if you subtracted 2 from 1, you'll get the same answer. Then you'll get minus y equal to minus 5, so y equal to 5. So it doesn't matter what is the order. But here I've taken 2 above 1 because the coefficient of the second equation, coefficient of y is higher as compared to the coefficient of y in the first equation, which is why I subtract 1 from 2. Right? Okay. Next. All right. So some problems here. So the first one is a equal to 2b plus half and 4b equal to 3. So what is the value of a? So two equations given, there are two variables, which means it's a system of equations. So how do we do this? So this is equation 1, this is equation 2. Generally, our purpose is to eliminate one variable. So luckily for us, when we look at 2, A is not present. So we can directly solve for B is 3 by 4 and substitute that in 1. So then A equal to 2 into B, which is 3 by 4 plus half. So this is 3 by 2 plus half, which is 2. Yes?
Yeah.
Okay. So this was easy because the second equation already had only one variable, so easy problem to solve. This one, 3x plus y is minus 1, y minus 2x is 4. What is the value of x plus 2y? Now, generally, when they ask you a combination, see the question stem and hence need to be slightly more alert here. So the question stem is asking you for a combination. Generally, when that is the case, you should use the combination method. So combine equation 1 and 2 in a way so as we get this. So such kind of questions generally can be solved. Otherwise, then you'll have to solve it simultaneously, which is the first methods by substitution. Solve it simultaneously, get xy, and then find the expression, which is long. So in what ways can 1 and 2 be combined to get x plus 2y?
Adding them,
Yeah, you can
adding
just
the
add them.
equations.
So when I add 1 plus 2, we get 3x. So I collect all the x terms together, 3x minus 2x, and the y terms together, and the constants on the RHS. So this is x, this is 2y equal to 3. So as you can see, so quick. So x plus 2y equal to 3. So this is the right choice. Longer method is to solve simultaneously, then find xy. So we don't have so much time to do. Okay. So identify the question type, question stem if it's a combination of two variables. That means generally this can be set up by combining 1 and 2 instead of solving for x and y. Next. Okay, so this is a word problem. Full Force's annual dance recital was attended by 205 people, each of whom purchased a ticket. So the number of people is 205. Now, who are the people? Children and youth tickets cost 3.5 and adult tickets cost 5. So clear bifurcation between children and adult. So that is what I will write here. I will write children and adult. I'll tabulate this data. Can I say cost per ticket? For children, it is 3.5 and for adult, it is 5. And what else is given? If Full Force collected 828.5 in ticket sales. So clearly one column here is cost per ticket, the other is number of tickets, and rather the number of adults or the children, right? Because what is the question here? How many adults attended? So the question is what is A? So I will just proxy for these variables as C and A to avoid confusion. So C is for children, A is for adults. So the number of children and adults are given by C and A. Now we can very easily set up the problem. It's given that 205 people attended, which means can I write the sum of C and A is 205? So this column will give me the equation C plus A is 205. And the first column will give me another equation because Full Force collected 828.5 and cost per ticket is 3.5 and number is C. So can I say value is 3.5 C for children, the value of the tickets, and for adults it is 5A. So the sum of these two should be equal to 828.5. So that's our next equation. 3.5c plus 5a equal to 828.5. This is equation 1, equation 2. So how do we set it up now? Got it, right?
Mm-hmm.
Yes. So how do we solve?
Combination?
Yeah. So can I say that I have a 3.5 here? Yes.
Yeah.
So to eliminate C, because can I say we want A? So I will eliminate C,
Mm-hmm.
which means first equation can I multiply by 3.5 and
Yeah.
write it below here. So 1 into 3.5 is basically 3.5C plus 3.5A equal to 205 into 3.5. So when I subtract the two equations, I get 1.5A.
Yeah.
Dropped off.
Sorry, what? Wait,
Sorry, I
you
just got
cut
dropped
out.
off.
Oh, it's okay.
Yeah. Let me know once you're able to see my screen.
Mm-hmm.
Yeah.
I still don't see it.
Okay. So we were doing it on a
I
calculator.
did. Oh, okay. I see it now.
Yes. Yeah. So did you solve it? What did you get?
No, I didn't solve it yet.
Okay.
$74.
Yes, correct. 74.
Mhm.
So whichever variable you require, retain that, eliminate. So here we need to retain A, eliminate C. So we combine 1 with 2 such that I multiply 1 by 3.5 because that's the coefficient of C in the second equation, and then subtract the two equations and we get A is equal to 74, right?
Yeah.
So slightly lengthy because we had to first set up the problem and then solve the equation. So word problems will take you more time on the test rather than equations already given to you will be work half done. Yes. Okay. A quant comparison problem. Two equations are given. Quantity A is P and B is 5. So can you solve this? Let me know.
Yeah. A.
A. Okay. So pretty straightforward. The second equation is giving the value of Q. So we put it here. So 5p plus 48 equals to 74. So 5p equals to 26, right?
Mm-hmm.
And p is equal to whatever, greater than 5, 5.2. So p is greater than 5, so A is the right answer. Great. Another question. So the question is asking for J and K, right? So which means we need to solve it and get J as well as K. So what is the best way to solve? So whenever there are, yes,
Combination here.
yes. So whenever there are fractions, okay? So
Yeah.
we try to take the LCM and just get rid of fractions. So no denominators.
Mm-hmm.
The first equation can be slightly modified. I will multiply by 15 on both sides, which is the LCM of all the three numbers, 5, 3, and 15. So multiplying by 15 on both sides, I get 3k minus 5j equal to 7. So that's my first equation. Second equation is 2k plus 3j equal to minus 8. So now how do we eliminate?
Uh,
Combinations?
you multiply.
Yeah, what will you
Would
multiply?
you
So can I
would you
say
multiply?
we have a plus and minus here, right?
Yeah.
So if I'm able to adjust the second equation, I should be able to add the two equations and then eliminate j altogether. So what is that multiplying factor? From 3, how do I get 5? From 3,
5/3.
yeah, multiply by
5/3.
5 by 3, correct?
Yeah.
So can I just multiply this entire equation by 5 by 3? So I get 10 by 3k plus 5j equal to minus 40 by 3. So now equation 1 and 2 can be directly combined and added. So once we do that, 5j cancel each other out and we get 3k plus 10 by 3k equal to 7 minus 40 by 3. So one way is to use calculator and reduce 10 by 3 and 40 by 3. What I generally do is I try to combine first and then use calculator. So I'll combine the k terms and I'll combine the constant terms. So this is LCM is 3. So 3, so I multiply both sides by 3 actually, because 3 is common in the denominator. So can I say I get 9 plus 10, which is 19k, equal to, I get 21 minus 40, which is minus 19. So k equal to minus 1. Ishani, just 1 minute. Huh?
Yeah.
So did you get J?
Not yet.
K is fine, right? K is minus 1.
Yeah.
So easier to work with this equation to get J.
Yeah.
Well, substitute in K minus 1 here. So minus 2 plus 3J equal to minus 8. Bring the constant on the other side. So 3J equal to minus 6, which means J is minus 2. So J is minus 2, K is minus 1. So obviously B is greater than A. Yeah, all okay?
Yeah. Mhm.
Yeah. So whenever there are fractions in an equation, take the LCM, get rid of the denominators, and then use combination so that one variable is immediately eliminated. Okay, so I generally like combinations. It's slightly faster rather than one variable as a function of the other and then substituting. So I don't like substitution, but whatever suits you, you can keep solving and figuring out what is best for you. This is faster generally, right? So this is what it is. All right, some different set of questions. So we are given two equations here, and we have been asked for which of the following values of W, so there's a W here, will the given system of equations have no solution? So two equations given. Clearly x and y are variables, but there is a constant w which the value is not known, and they're asking us what is the value of w. So two variables are x and y here clearly, and w is a constant, but its value is not known. What we know for sure is the system of equations have no solution. This is possible when the lines are parallel, when they never meet. So when the lines are parallel, there will be no solution. When the lines are intersecting, there will be a solution, one solution. And when you are just given one equation, just one equation. So in both the above cases, there are two equations. But if you're just given one equation, there will be infinitely many solutions. So this is an important, these are important points. You can just make note of case A, B, and C. So we could be tested on these. So lines are parallel, which means no solution. Intersecting lines means one solution. And if only one equation is given, it means infinitely many solutions. And how is that possible? Suppose one equation given is x plus y equal to 5. So can I start putting x equal to 0, y will be 5? But if x equal to 1, y is 4. Is x equal to 2, y is 3, and so on and so forth. So infinitely many of these combinations. And hence, when only one equation is given, we could have infinitely many solutions, which means infinitely many combinations of x and y, which will satisfy that one equation. So now, with this knowledge, can we solve this question? So, for which of the following values of w will the given system of equations have no solution? What do you think? No solution means parallel lines.
Could we go through this question? I'm not really sure.
Okay. So first equation is 3x minus 4y. So let's just write this. 3x minus 4y equal to 10. First equation. Second equation is 6x plus wy equal to 16. Now what are they asking? They are asking us what is the value of w such that the system of equations have no solution. Okay? Which means they are parallel to each other. If they are parallel to each other, can I say their slopes are equal? Slopes are equal, correct? So if the slopes are equal, all that I have to do is, can I say what is the slope for, so there are two ways of solving this. Okay, I might want to take another slide here. So 3x minus 4y equal to 10. 6x plus wy equal to 16. So how will we set this up? Now, equation 1 and 2 are parallel lines and hence have same slopes. Yeah. Two ways of solving this. So we know that ax plus by equal to c. So what is the slope of this line? So can I say y equal to mx plus c is the generic equation where m is the slope, correct? So when I have ax plus by, I have ax plus by equal to c. Can I write that in the form of y equal to mx plus c? Yes. So by equal to minus ax plus c. So y equal to minus a by b x plus c by b. So my slope becomes minus a by b. So whenever you have an equation like this, what is the slope? Slope equal to minus a by b. As simple as that. So slope of ax plus by is plus c is minus a by b. So I've given you the logic of y minus a by b. Yes? Which
Yeah.
means if I were to ask you what is the slope of the first line, can I say
A
minus
over
a by
4.
b? So 3 by 4.
Yeah.
Okay. And what is the slope of the second line, please?
Minus 6 over W.
Correct. Minus 6 over w. Can I equate these two?
Yeah.
Because they have the same slopes. So can you tell me what is w, please?
A minus 8.
Yeah. Minus 8. So this is the lengthy way, by the way. Shortcut. So I'll put the shortcut out here. When I look at the two equations, one equation is 6x plus wy, which is what we need. We need w, right? So this should be your master equation, which is number 2. Equation 1 is 3x minus 4y equal to 10. If I were to multiply 1 by 2, I will get the same coefficient of x, which means I get 6x minus 8y equal to 20. So now I can directly compare and contrast. Coefficient of x is the same. This is equation 3. So comparing 2 and 3, coefficient of x is the same. So the coefficient of y also has to be the same. So w equal to minus 8. So this w should be equal to this. So this is the other way of solving. Second method is preferred, shortcut. Yes. So
Yeah.
slope is minus a by b if it is ax plus by equal to c always. So you can
Mm-hmm.
just make a note of that, number 1. Number 2, we can use the shortcut, which means the constant term which is known, both coefficients should be the same. If you're solving a parallel line setup problem like this. Okay?
Yeah.
All right. Let's move on. Another variety. If the system of linear equations has infinitely many solutions and c is a constant, what is the value of c? Infinitely many solutions means what? Single line.
There's only one. Yeah.
Yeah, just one equation, which means both equations are the same. If both equations are the same, all that I have to do is I have to match the coefficients. So if there is half x here, how will I get 6 there? Can I say just multiply by 12? So
Yeah.
this equation becomes 6x minus 8y equals to 12c. And the other equation is 6x minus 8y equals to minus 1. Both are same, which means by comparison, both these terms should be equal. So c is minus 1 by 12. Okay. One last question of this variety. Two equations given. What is the value of k by h? So as you can see, two variables x and y involved, and there are two constants h and k. If the xy solution of the given system of equations is minus 5 by 2, solution is given, which means can I say they are intersecting lines?
Mm-hmm.
And the solution is also given, minus 5 comma 2. And you're asked what is k by h. So how do you think we can solve this? So one way is you can substitute the value of minus 5 by 2. So substitute x equal to minus 5 and y equal to 2 here inside. So you will get two equations, one involving h and the other involving k. So let's use that method. So method 1. So I put x minus 5 and y minus 2. Sorry, y equal to 2. So the first equation becomes h into minus 5 minus 5 into 2 equals to minus 15, which means minus 5h. I can bring this constant on the other side. Minus 15 plus 10 will be minus 5. So h is 1. So the first equation gives me h equal to 1. The second equation, which is this, kx. So put minus 5 and 2 in equation 2. So k into minus 5 plus 2 into 2, which is 4, equals to minus 20. So k becomes minus 24 by minus 5, so 24 by 5. If I look at the options, they are fractions, so I need not solve this on the calculator. Let us put these in fractions only. So now we can find k by h, and that is 24 by 5 divided by 1, 24 by 5.
Yeah.
Method 2 will involve combinations, combining the two equations to delete one variable. But we will not use this. And the reason is because we know the solution. We only combine the two equations when we do not know the solution. Solution is known, so directly substitute for x and y in the two equations and get what is h, what is k. So this method is preferable, method 1. By the way, to combine the two equations, I would have multiplied the second equation by 5 by 2 and just added the two equations. Yeah, even that is possible. And then substitute for value of x because only x remains. But not needed here. So method 1 is better, simpler. So these were some of the variations in systems of equations. So we learned how to solve equations by combinations ideally or by substitution. And we learned the three different variants. The first variant is when the lines are parallel to each other, which means they have no solution. So then their slopes will be equal. So you can equate the slopes and get the unknown constant. In the second setup, if the lines are intersecting, they will have one solution. In the third setup, only one equation is given and it will have infinitely many solutions. Yes. So this is an important part. Okay. So this is what we have. Next topic. We have some time, right? 15-20 minutes more.
Yeah.
So next topic is inequalities. So what is inequalities? Inequalities will give you a range of values. Example, x greater than 3 and x is an integer. So on the number line, when I draw the number line 0, 1, 2, 3, x greater than 3 and being an integer, can I say the range becomes from 4 to infinity? So I can write this as the answer. So range of values of x becomes this. So in inequalities, you always have a range to work with. Now, if two inequalities are given, so this is the first setup. Second is two inequalities are given. Suppose I write x greater than 3, but x less than 6, and x is an integer. It means this kind of a problem can be solved graphically, where x greater than 3, can I start drawing from 4? So 4 till infinity is the solution of the first inequality, which is x greater than 3. X less than 6, on the other hand, can I say will be any value which is less than 6, which means 5 and below is the answer for the second inequality. The final answer is, can I say, the intersection of 1 and 2 on the graph. So when I intersect both, I get the only common area, as you can see, is this part. This part is the only common area. And hence there are two answers, 4 or 5. So the range of values which satisfy both these inequalities will be x equal to 4 or 5. Given the fact that x is an integer. Make sense?
Mm-hmm.
If I were to ask you, x not an integer, which means x is a rational number, and I give you the same set of equations, x greater than 3, x less than 6. How do we solve these? Similar fashion. So now x greater than 3, can I say anything above this will be my first equation?
Mm-hmm.
And second equation is what? X less than 6. So if this is 6, second equation starts from here. So the common area is this. So my answer will be 3 less than x less than 6. So this is the solution. So always look at the intersection. Always check if the answers are integers or real numbers. If they're real numbers, then the intersection is the area. If these are integers, then you will get the intersection as a range of integers, yes, or discrete values. Otherwise, you will get a continuous range like this. All right. I've already explained this. Just one thing here is that suppose you have an inequality like this, minus 2x greater than 4. Now, if I want to remove this negative term, so whenever I multiply any inequality by minus 1 or any negative number, the signs will flip, which means greater will become less than, or less than will become greater than. So for instance, if I want to remove this minus 1 from here, original is minus 2x greater than 4. If I want to multiply by minus 1 on both sides, this sign will be flipped and I get 2x less than minus 4. So always flip the inequality whenever you are multiplying by a negative number. If you're multiplying by a positive number, no need to flip. the sign. Yes?
Yeah.
Okay, so this is an important rule. You can just make a note of this. And the one on the previous slide, the intersection, is how we solve inequality problems. So let's go and check some of the questions. This is another kind of question type on Quant, wherein they will give you a question stem, and they will ask you indicate all the values which satisfy the equation. Your multiple choices are possible in this question type. So you will only select multiple questions, multiple choices when this statement is given, indicate all such values. Then you can select multiple choices. So this is another type of MCQ, but a multi-choice MCQ. Yeah, so how do we solve this equation? It's not an equation, it's an inequality. So 2x plus 3 greater than 4x minus 9. So can I say collect, as always, collect the x terms together, the variable terms together and the constants together. Coefficient here is more, so I bring 2x on the other side and I bring minus 9 on the other side. So it becomes 12, 3 plus 9, 12 greater than 2x. I can divide by 2, so it becomes x greater than 6 greater than x. And I can also write this as x less than 6. So if this is the solution, can you tell me which values will satisfy?
-6, 0, and 3.
Yeah. Right. So when you want to solve an inequality, collect all the variable terms together, the constants together. If you are multiplying by a negative number by chance, flip the inequality. So the first three choices are the right ones, correct? Now, can you solve this, please?
Yeah.
Now, if you observe the question properly, this is a negative question they're asking. They're asking you which of the following could not be a value of x. So negative, which means they're asking not a solution. So it will lie outside the range of the inequality. So always properly read the question. This is a common mistake which many do. Indicate all such values. They'll solve the inequality correctly and mark the choices in the range, but actually it's a negative problem which is given, which is not a value of x, which means outside the range of the solutions. Okay, so can we solve this, please?
5 and 8.
So 3x divided by -2 greater than -6. So if I want to take -2 on the other side, what do I do?
You flip the sign.
Flip the sign. So can I write 3x less than equal to 12 or minus 3x? Am I flipping the signs? Just multiplying by -2, right? So this remains as is.
Yeah.
So multiplying by -2. So -6 becomes 12. So 3x less than, and the signs will flip because you're multiplying by -2. So x less than equal to 4. So what is not a solution? 5 and 8. All these are less than 4. So these are solutions and these cannot be the right answer. So what are not solutions are the right answer. Perfect. All right, next question. A quant comparison. So there are two inequalities given. One is involving only x variables, the other involving only y variables. So these can be easily gotten in terms of x and y. Yeah. So can
Yeah.
we simplify the first equation? Can you tell me what will it look like?
You multiply 3x plus 2 by 2
Or
and
by 4?
then
LCM. So remove the denominators, remove all the fractions. So multiply both sides by 4, correct?
yeah.
So 3x plus 2 greater than 2 times 5 plus x. So this is greater than 10 plus 2x. So this is simple. Take all the x terms together. So x greater than 8. And can you similarly solve for equation 2 for y?
Hmm. Multiply both sides by 15 then.
Correct, 15. So we have 6y less than 3 times 10 plus y. So 6y less than 30 plus 3y. So 3y less than 30, y less than 10.
Yeah.
Yes?
Yeah.
So how will you tackle this problem now? Now that we have solved for the range of x and y, but quantities are not x and y here. Quantities are some other numbers or combinations of x and y. So your 2x minus y, minus 1, sorry, is quantity A. I know for a fact that, so let's solve this here. So can I say x greater than 8? So always bring it in this format, the quantity 1 format. So can I say you need 2x minus 1? So first of all, I'll multiply by 2 on both sides and then subtract 1 from both sides. So can I say I get 2x minus 1 greater than 15? Always solve for the expression of A or B. So when we
Mhm.
solve for the expression of A, we get 2x minus 1 greater than 15. And if we solve for the expression of B, we know y less than 10. So 2y, can I say, will be less than 20. And 2y
Mhm.
minus 7 will be less than 13. So which is greater?
Hmm. 2x minus 1.
A, right?
Yeah.
Because it is greater than 15 and the other is less than 13. So clearly A is higher and B is lower. So it seems that we might not be able to solve it because these are inequalities, but when we look at the expressions and simplify for the expressions, one expression is greater than 15, the other is less than 13. So clearly A will be higher than B. So
I
A,
have a question.
sorry, yes,
If B was less than like 17, then the answer would be D, right?
correct. So
Okay.
if B is less than 17, so 2y minus 7 less than 17, right, is the question.
Yeah.
Then all the three things are possible,
Hmm.
which means either A could be higher or B could be higher. And if there is this conflicting answers, that sometimes A is higher, sometimes B is higher. Answer is D.
Mm-hmm.
Absolutely. So here we could have solved this problem because in the first expression is higher than 15 and the second expression is lower than 13.
Mm-hmm.
So here it is clear that E1 is greater than E2. But yes, whenever there's an overlap, you will not have either higher or lower. So your solution is possible because of non-overlapping.
Mm-hmm.
So solution possible. Okay. Shall we proceed?
Question.
Yes.
What is written above the arrows on the number line at the bottom? Is it E1 and equation 1 and 2?
Which one? E1 and E2. Expression 1 and
Okay,
expression.
okay.
Yeah. Expression 1 is your 2x minus 1.
Yeah.
This is expression 2.
Mm-hmm.
Yeah.
Okay.
Yes. So these are the kind of questions which are tougher generally. Quant comparison, yeah. So this could
Mm-hmm.
lower your score. So hence we need to be extremely careful when we are solving quant comparison because there is this tricky choice which is D which cannot be solved. Yeah, so we have to be absolutely sure whether D is right or not. And we only select D when we have scenarios where A is greater than B or A is less than B. If we have both the scenarios, then the answer will be D. Yes? Which
Yeah.
means we need at least one scenario of A greater than B and one scenario of A less than B. All right. Last part for today, quadratics. So quadratics are of this form: ax squared plus bx plus c. How to solve the quadratic is important. There are two ways of solving the quadratic. One is factorizing them by observation, and the other is the solution method. So if this is your equation, ax squared plus bx plus c equal to 0. Solution method will give x value as minus b plus minus root of b square minus 4ac divided by 2a. This is when we cannot factorize. We should use the solution method. If you can factorize, it will be of this format: x plus c1 into x plus c2 equal to 0. So my solution will be either x plus c1 is 0 or x plus c2 is 0. So I can write x equal to minus c1 or minus c2. Correct?
Yeah.
So let's tackle some of these quadratics. X squared plus 5x plus 6 equal to 0 is the equation. And quantity is squares of the sum of the roots of equation. Square of the sum of the roots. And quantity B is 25. So how do we solve this? So one, as I mentioned, the first method is factorization. Wherever possible, we'll try to factorize. Now, when I look at an equation, x squared plus 5x plus 6 equal to 0. First of all, I have to ensure that my coefficient of x square is 1. Ensure this coefficient. So if we had 2x square, I would have just divided the entire equation by 2. That's point number 1. Second is, this term gives us the product of the roots, the constant term. And this gives us the sum of the roots, the coefficient of x. So whenever we want to factorize, we use the factorization method now. If we want to factorize, we start with product of roots, easier to do. 6 can be written as 1 into 6, can be written as 2 into 3. So we have two choices for the roots, 1, 6 and 2, 3, correct?
Yeah.
I could have also written minus 1 into minus 6 and minus 2 into minus 3, by the way.
Mm-hmm.
So actually there are 4 combinations. But if I look at roots, sum of roots is 5, right?
Yeah.
So can I say I will select this combination? So product is 6 and sum is 5. Right? So we will select this 2 and 3, which means when I factorize, it looks like this. X plus 2 into x plus 3 equal to 0. And what are the roots? X equal to minus 2 comma minus 3.
Yeah.
Please note, x plus c1 equal to 0 means x equal to minus c1 is the answer. So if you have plus inside here as a factor, the answer is the minus of that, correct? So x is minus 2 or minus 3. Because if I put minus 2, this equation becomes 0. If I put minus 3, the equation becomes 0. So if these two are the two roots of the equation, what are they asking in quantity A? Square of the sum of the roots. So what are the sum of the roots? Minus 2, minus 3. And can I say square of that? And what is the square of that? 25. So the two quantities are equal, and hence this is the right answer. All good?
Question.
Yes.
If you already see that the sum of the roots is 5 from the equation, because you said the 5 there in the equation at the top is sum of the roots, right? Always.
Yeah.
Then can't you just directly use that and square it?
You can do that as well, because they're asking. So I was illustrating how do you factorize. So that's why I solved this. But here you don't need to solve, because here they are asking you the sum of roots. So directly take this and square it up. But please note one thing. Although I've told you sum of roots is a function of this term 5, right?
Yeah.
But actually, if you go to see, sum of roots will be minus 5, because the roots are minus 2, minus 3. Which means if I look at the equation which looks like this, if this is the equation, ax square plus bx plus c equal to 0, a more generalized quadratic, the product of roots is given as c by a, and the sum of roots is given as minus b by a. So sum of roots is always the negative of the coefficient of x.
Okay.
When I talk about factors, This 5 is the sum of the factors, like sum of x plus 2, so plus 2 and plus 3. But in terms of roots, it is minus of the coefficient. So please remember this. This is more generic. You can make a note of this. And hence I said whenever you get a in front of x squared, just divide by a. So hence you get it in the format of x squared plus. So when I rearrange this, I get x squared plus b by a x plus c by a equal to 0. So this is product and sum will be minus of this in terms of roots. In terms of factors, plus. Got it?
Yeah.
So when we have to factorize like this, I will not take minus of this. But if they're asking sum of roots, then it will be minus of the coefficient. So here you're right. Directly we could have supplied this. No need of even solving. So 5, which means minus 5 is the sum of roots, square of that. Straight away you get the answer. So this is pretty straightforward that way. But then I wanted to illustrate the whole factorization and the difference between roots and factors.
Yeah.
Okay?
Yeah.
All right. Next. Generic form, ax squared plus bx plus c. So what is the product of the roots here?
Minus 30 over 2, so it's minus 15.
Correct. Minus 15. And what is the sum of the roots?
Minus 2.
Minus b by a. So minus 4 by 2 minus 2. So which is higher?
B.
B. So in quadratics, three things are important. One is the solution x equal to minus b plus minus root b square minus 4ac divided by 2a, the formula. Second is the factorization method. And third is knowing from this generic form what is the product and what is the sum of the roots. Yes?
Yeah.
Okay. All right. Inequality and quadratic together here. Let's see if we can solve this. So we always start with the quadratic and try to find what is x. So x squared plus 5x plus 12 equal to 8. I can bring the constant on the other side. Always on the RHS you should have a 0. So x squared plus 5x plus 4 equal to 0. Product is 4 and the sum of the factors is 5. So can I write combinations of 4 will be 1 into 4?
Yeah.
And if I add 1 and 4, they will give me 5, right? So this is the right choice, which means factorization will give me x plus 1, x plus 4 equal to 0, which means x is minus 1 or x is minus 4. But what is they have also given us one inequality which x satisfies. So they're saying x is less than minus 3, which means I will only select minus 4 from here. So actually x equal to only minus 4. So this is similar to the intersection setup. So when I write x less than minus 3, it means x can take any value to the left of minus 3, but I have x equal to minus 1 and x equal to minus 4. So the intersection of the region and this value will be minus 4, which is why I've written x equal to minus 4. And if x equal to minus 4, what is the value of x plus 2?
Minus 2.
So that's the answer. Yep.
Yeah.
All good. So they can
Yeah.
combine different types of equations like inequalities, quadratics, and ask you a combined question. All right. So what do we understand from this?
I'm not sure.
So they're asking which of the following expressions must be the square of an integer? Which means, can it be expressed as ax plus by square is what they're asking.
Yeah.
Any of these are these of this format is the question. So let's tackle the first part, choice A. So I can simplify this. Can I say this is x plus y into x minus y is x square minus y square, the
Yeah.
identity, plus 8xy plus 17y square. Collecting all the terms, x square plus 8xy plus 16y square. Can I write this in this format? So
Yeah.
no coefficient of x, right? So I can
Mm-hmm.
write x, and the coefficient of y square is 16. So when I take the root, can I write x plus 4y square whole square will give me this, correct?
Mm-hmm.
So basically a plus b whole square, a square plus b square plus 2ab is what we are trying to use. So ax plus by whole square is a square x square plus b square y square plus 2ab(xy). So they're asking if any of these expressions can be given as a square. So some of the quadratics can be written as a square term. An example is x squared plus 2x plus 1 equal to 0. So can I say this looks like a square of x plus 1?
Yeah.
Yes. So what is the answer here? X equal to -1. So whenever any quadratic can be written as a square, if quadratic is a square, there is only one root.
Mm-hmm.
And here it is -1.
Yeah.
Yeah. Similarly, if I write x square plus 4x plus 4 is equal to what? X plus 2 whole square. Yeah. So
Yeah.
the previous question is exactly asking that, but in a generalized format, ax plus by whole square.
Mm-hmm.
So can I say the first choice, we are getting a square, so that is the right choice. What about B?
Also.
9x to the power 4 minus 12 x square y square plus 4 y raised to 4. Now, this can I say is 3x square, and this is 2y square.
Yeah.
So when I multiply 3 with 2 and 2, I get 12, which is the middle term.
Yeah.
And there's a minus. So can I say this looks like 3x minus 2y? And in fact,
Yeah.
here we are talking about squares inside because it's raised to 4. So I will write 3x square whole square and 2y square whole square.
Yeah.
Yeah. So this can also be written in the format of a square term, which is 3x square minus 2y square whole square.
Yeah.
Correct?
Mm.
Okay. And so this is also right. And what about C? C is x to the power 6 plus 2x cube y cube plus y raised to 6. Can I write this is in terms of square is x cube square, and this
Yeah.
in terms of square is y cube square.
Yeah.
And hence this expression becomes x cube plus y cube whole square,
Yeah.
which will give us these three terms on expansion. So this is also right. So the answer is all of them are correct.
Mhm.
Yes?
Yeah.
Right. So such kind of questions, whether the expressions are squares of integers, for that you need to evaluate if you can collapse the equation into a square term, like
Mhm.
ax plus by square.
Yeah.
And I can in fact generalize this. I can write ax raised to n plus by raised to n square.
Yeah.
Okay, so that also. So for instance, these two variants, B and C, are of this nature.
Mhm.
All right. So this is what we have. Okay. New question. So how do we solve this? Three x raised to 2 by 3 plus 2 cube root of x. Can I write this as x raised to 1 by 3? So this is x raised to 1 by 3 minus 8 equal to 0. So this is the expression. And clearly, if you can see, this x raised to 1 by 3 looks like a commonality. So I can rewrite this equation as 3 into x raised to 1 by 3 square plus 2x raised to 1 by 3 minus 8 equal to 0. So I'm using the fact that x raised to a raised to b is x raised to ab. So x raised to 2 by 3 is nothing but x raised to 1 by 3 square. Correct?
Yeah.
So can we identify this is like a quadratic now, where I can substitute y equal to x raised to 1 by 3. Substitute. So then my equation becomes 3y square plus 2y minus 8 equal to 0.
Yeah.
Is that right?
Yeah.
Okay. So what is y?
1 x to the power of 1 by 3.
So clearly difficult to find factors here. First of all,
Yeah.
because this has a coefficient which is not 1. So if I divide the equation by 3, it becomes complicated. 2 by 3 minus 8 by 3, difficult to find factors.
Yeah.
So the best way to solve this is using the solutions. Y equal to minus b plus minus root of b square minus 4ac divided by 2a. So let's substitute. B is equal to is equal to 2. So we have minus 2 plus minus b square is 4 minus 4 into a which is 3, into C, which is minus 8, divided by 2A, and A is 3. So when I simplify, y is equal to minus 2 plus minus, inside the root is minus minus will become plus. So can I say we have 12 into 8, 96, correct?
Yeah.
Plus 4. So it becomes root of 100 inside, divided by 2 into 3. And root of 100 is 10. So we have minus 2 plus minus 10 divided by 6. So y can have two values, minus 2 minus 10 by 6 or minus 2 plus 10 by 6. If I take the first one, we have minus 2. And if I take the second one, we have 4 by 3. 8 by 6 is 4 by 3. Correct?
Yeah.
So two solutions for y. Which means x raised to 1 by 3, which is y, will either be equal to minus 2. And if that is the case, what is x? Take cubes on both sides, right? So x raised to
Yeah.
1 by 3 is minus 2. So x becomes minus 2 raised to 3, which is minus 8. This is one solution. And the other solution is x raised to 1 by 3 could also be 4 by 3. Which means x could be cube of that. 64 by 27. So what is the answer?
B.
Which one?
B.
D. Okay. And why is that?
Um, I said B.
B or D?
B.
D. And why is that?
No, I said B.
Oh, you said B.
Yeah.
And why is the B the answer?
Because because minus 8 is less than 64 over 25.
Yeah.
And then 64 over 27 is also less than 64 over 25.
Absolutely. You're right. So the answer is B.
Yeah.
Always. So clearly there are two scenarios here. X is minus 8 and x is 64 by 27. But in both cases, it is, so this is A. In both cases, it is less than B, which is 64 by 25. And hence, since both scenarios are giving less than B, answer is this. If we had one value to the left and one value to the right, answer would have been D.
Yeah.
Yeah. But here, since both, so in this